Hi, so first what we're going to do is we're going to just recap the basic concepts of integration, and then we're going to do certain concepts like area under the graphs and area bounded by multiple graphs. So just to begin up with, some of the basic stuff that we need to know for integration are like the first thing is when you're integrating, let's say the basic functions such as integration of x to the power n. Integration of x to the power n is x to the power n plus 1 over n plus 1. Similarly, if you are integrating ax plus b to the power n, where you replaced x with another linear function, so that becomes ax plus b to the power n plus 1 over n plus 1, and don't forget to divide by the coefficient of x, which is a. So this is just a recap. I have explained all of these in my previous lesson. Now next one is when you're integrating, let's say 1 over x, integration of 1 over x is ln x plus c. Now don't forget to put plus c if it is indefinite integration. Now if you have integration of 1 over ax plus b, so if you've got 1 over ax plus b integration, it is ln ax plus b over a plus c. So these are some of the important things that keep coming in additional math exam. Now let's take other example, like for example, if I'm integrating e to the power x, integration of e to the power x is e to the power x plus c. So if you got integration of e to the power ax plus b, integration of this is going to be e to the power ax plus b upon a and plus c. So this is the second one. The third one is if you got, let's say, sine x, the integral of this is negative cos x plus c. So if you got sine ax plus b, integration of this is going to be negative cos ax plus b, and don't forget to divide by the coefficient of x. So that's about the indefinite integration. Some of the formulas I'm not writing here, but the logic is the same. So if you're replacing x with any other linear function, you're just going to replace ax plus b, divide by the coefficient of x, which is a. So this is just the recap part of it. Now let's kind of take the questions that are we generally get. Now one of the question is, we are given that second derivative is, let's say, negative 3x plus 5, and it has been given that the gradient at x equals to 1 is, so gradient is dy by dx, so gradient is 5, and it passes through 1 comma 5 as well, or let's say here I'm giving 1 comma 6. So first what you're going to do is, since the second derivative has been given, so we integrate it, so we're going to get the first derivative. So dy by dx is going to be integration of negative 3x plus 5. So this is going to be negative 3x squared over 2 plus 5x and plus c. So here just remember that if you got in a constant, you can just take it outside, keep as it is. Integration of x, you would apply x to the power n formula, which is x to the power n plus 1 over n plus 1. So this is the basic recap of the formula that I have. And the second one is, now once you got this, you got to find out the constant. So with this given condition, I need to find this, what's this constant. So when x is 1, the derivative is given as 5. So when x is 1, so 5 equals to negative 3 by 2 plus 5 plus c. So if you simplify this, so c anyways, the 5 get cancelled here. So we get c is 3 over 2. So once you got c is 3 over 2, I can replace out here instead of c. Now we're going to put 3 over 2. So this part is now the expression for the derivative function. Now to get the exact function, or let's say the y equals to, so if I integrate this once again, so if I integrate negative 3 over 2 x squared plus 5x plus 3 over 2, I'm going to get my function. So step is, if you're integrating x squared, integration of this is x to the power 3 over 3. Of course, there is dx here. So here what we get is negative 3 over 2 as it is, times x cube over 3 plus 5x squared over 2 plus 3 over 2x, and of course plus c. So cancel and cancel this part, and now you're going to put x as 1 and y as 6 to get the constant. So I'm just going to erase this step. So you're going to take x as 1 and y as 6. So 6 equals to, you get negative half plus 5 by 2 plus 3 by 2 plus c. So once you simplify this part, so you get c equals to, so this is 3 by 2, this is 8 by 2. 8 by 2 minus 1 by 2 is 7 by 2. So c equals to 6 minus 7 by 2. And if you simplify, you get the constant. You plug out here, and that's your exact function that you needed. So remember that whenever you've been given second derivative, you integrate it to get the first derivative. Once you integrate that, you get the function. So this is a very common question, 7 to 8 mark question in additional math exam. I'm going to take some more questions in our later on. So I'm going to take now the key concept, that is around the area under the graph. Now, as we know that if you have a function, you take the derivative, you get the slope of the slope formula. Similarly, in integration, if you integrate a function with certain limit, which is like definite integration. So suppose if you got a function f of x from a to b, this will be nothing but your area under the graph, provided the function f of x is above x-axis. So suppose this answer is g of x. So you put the limits a and b. A is this value and b is this. So this g of b minus g of a you get is the area under the graph. This is the area under the graph. And of course, let's take an example. Suppose if I got a y equals to x square graph, and I wanted to find out the area bounded by the graph and x-axis from negative 1 to 1. So if I integrate y equals to x squared function, so if I integrate x squared function from minus 1 to 1. So this is going to be the area that I'm looking forward to. So this is going to be x cubed over 3. Put the limits negative 1, 1. This is going to be 1/3 minus of minus 1/3, which is 2/3. So this area is overall basically 2/3. So if I find out the area bounded by the graph and the curve, it is that answer. Now, one of the very common questions that is assessed in ADMATH is on this logic. So suppose you have been given a function and they'll ask you find out equation of tangent at a certain point. So mixing up the two things. So let's say here, so here we got the function and I'm drawing the tangent at this point. So let's say there's the tangent, and the function that is given is, let's say y equals to x squared itself, and the point that is given is, let's say 2, 4. So they will first ask you find out the equation of tangent when x is 2. So you're going to find out, let's say, obviously dy by dx. So dy by dx is 2x. Plug in this x coordinate out here. So dy by dx is basically 2 times 2, which is 4. So slope of this tangent that we are seeing is actually 4. So this tangent has got the slope of 4. So y equals to 4x plus c. Now to get the exact coordinates of c, I'm going to plug in x is 2 and y is 4. So 4 equals to 4 times 2 plus c. That gives me c as negative 4. So once I got c as negative 4, that's the equation of this tangent is y equals to 4x minus 4. That's a proper answer. So basically this cuts here. If I equate this to 0, I'll get x as 1 as the answer. So this is going to cut, this tangent is going to cut x-axis at 1, 0. So basically, to get the x-intercept, you plug in y as 0. To get the y-intercept, plug x as 0. As simple as that. So this is generally a sub-question for 2 marker. So just make sure you know that. Next part is, how do I calculate this area now? So let's say they'll ask us, find out the area bounded by this curve and the line. Now how can I calculate that? So if you simply understand, if I calculate the area between the curve and the line x equals to 2, let's say if I take this entire area first, I'm going to find this entire area of the curve and between 0 and 2. So x squared, you integrate from 0 and 2, so you get x cubed over 3, put the limit 0 and 2, so you get 8 cubed, 8 over 3 as the area. So you plug x as 2 here, and if you plug x as 0, anyway that answer is 0. So the answer that we get is 8 over 3 here, and now to get the exact, exact area, I'm going to find the area of this tiny triangle. So this triangle, I'm going to subtract from this area. So we got this entire big part, and now from here, I'm going to cut down this triangle. So you can see height is 4 and base is 1 for this triangle. So you can use calculus, or you can use just area of triangle. So area of triangle is half base is basically 1 and height is 4. So this cancels and you get the answer as 2. So here this area of this part is 2. Now to get the shaded area, I'm going to do 8 over 3 minus 2. So that's nothing but 2 over 3 as the answer. So area of the shaded part that we have got, basically after everything, this part is going to be 2/3. So that's how I calculate the area and mixed concepts all together in one particular problem. Now let's just take one problem that has got the multiple approach. Okay, but before that, there is a straightforward formula if you have got the area bounded by two graphs. So suppose if I've got one of the function is f of x, another function is g of x, and if I know their intersection, so in lots of cases you're asked to solve simultaneous equation. So first you're going to find out, let's say, this intersection A, this intersection B, using generally the simultaneous equation approach. And then you're finding out, let's say, area bounded by this part, area bounded by both the graphs. So if you got f of x, assume that this is the upper curve and the g of x is the lower curve. So here we got a straightforward formula. You can find out the area bounded is, you first find out the intersection A to B, and then you do upper curve f of x minus lower curve, which is g of x. So this gives us the area bounded by two graphs straight away. Now just to illustrate this concept, I'll just repeat again. F of x is upper function, g of x is lower function. So just subtract those two and you get the area bounded by two graphs if you integrate from A to B. Now just take an example. If you got a simple example is if you got y equals to x squared and y equals to x cubed. So if I look at the function, x squared function is like this, and x cubed function is basically, I'll just redraw it. This x squared function, this x cubed function here down here, and x squared goes up. So here you can see the x squared function is above. Now they're asking us to find out what's this tiny little area. How can I find out this particular area? So when you're finding out this area, which is, let's say, 0 to 1, how do I get that this is 1? You solve it. So if you equate x squared equals to x cubed, so x squared in bracket 1 minus x, so x squared will be 0, and you get, so 1 minus x is 0, so x is 1, and you get x is 0. So x is 1 and x is 0 basically here. So now out here, if you wanted to find out the area, which is from 0 to 1, you basically integrate, which is upper curve is x squared, so upper curve is x squared minus lower curve is x cubed, which is from 0 to 1. So upper curve minus lower curve, and you integrate from 0 to 1. So what we get is x cubed over 3 minus x to the power 4 over 4 from 0 to 1. So now I plug in x as 1 here, so you get 1/3 minus 1/4. And if you plug 0, both the answers are anyway 0. So you get nothing but 1 over 12. So this area that we got is actually 1 over 12. So if this is exact area bounded by the graphs, remember that it is always going to be upper curve minus lower curve. First you find the intersection, and then you are going to solve for the exact value by obviously integrating using the logic and the formula. Suppose now, a very common question is that suppose they ask you, if this is, let's say, part of the graph, suppose this is 15, this is 8, and this is 7, consider this is unsymmetrical, and this is given as the function f of x from 0 to a, b, and c. So now if they ask us that suppose this particular area is 15 units squared, this area is 8 units squared, this area is 7 units squared, what exactly is the value of the integral from, if I integrate from 0 to a f of x? So if I integrate from 0 to a f of x, that's going to be 15 straight away because it's above x-axis. But if I integrate from a to b f of x, this answer is going to be -8 because this is below x-axis. Any area, any integration that you calculate from a to b below x-axis is going to be negative. Similarly, from b to c, if I integrate from b to c f of x, so lots of times this confusion comes is that they don't understand how this positive negative system work. So our next part here is, if I integrate from a to c the function f of x, if I integrate a to c the function, does it give me the exact area bounded by the graph from a to c? And this answer you simply can find out. This answer is going to be 15 minus 8 plus 7. So this is 22 minus 8, that's like 14. So this is not the area. So area is 15 plus 8 plus 7. So if they say that this is the area, that's not correct. That's not right. So when you're finding out the area, what you're going to do is you're going to actually split this up in different parts. So when you're splitting it in different parts, like 0 to a to b, and then b to c, you're going to get some part as positive, some part as negative. So this is positive, this is positive, this is negative. So make this absolute value. So here my area would be 0 to a f of x plus a to b f of x plus b to c f of x. This answer, but this one you're going to take the absolute value because that was the part which is the below x-axis. So I hope this kind of explanation helped you to understand the concept of the additional math area under the graph. I'm going to take some more problems in our next lesson basically. So that's it. Thank you.